Okay, so I will be solving this question from paper 5 of A-level physics. The variant is this right here. So the question states a student investigates stationary waves with an elastic cord of circular cross section attached to a load. This is shown in this figure. When the frequency of the vibrator is F, the cord vibrates with the stationary wave pattern shown. The student investigates how F varies with the cross-sectional area A of the cord. It is suggested that the relationship between F and A is this, where L is the distance between two nodes, meaning these are the nodes, M is the mass of the load, and K is the constant. Design a laboratory experiment to test the relationship between F and A. Okay. Explain how your results could be used to determine a value for K. You should draw a diagram on page 3 showing the arrangement of your equipment. In your account, you should pay particular attention to the procedure to be followed, the measurements to be taken, the control of variables, the analysis of data, any safety precautions to be taken. Okay, so for this question, there are some pointers that you need to keep in mind. So even though these pointers are more than enough, but you can make it more simple for yourself to write the pointers that tells you exactly what to write. Meaning, let's first formulate an answer. So first thing we should write when solving question 1 of P5 is the variables. Now what kind of variables we need to write about? The independent variable, the dependent one, and what constants are there, meaning constants. So this is not part of the variables. Uh, Constants. Now these come under the heading of defining the problem, or you can say the experiment. So always start your questions by answering this. Other than that, then we're supposed to write about methods of data collection. Meaning if you're measuring mass, for example, then how are you going to measure mass or the diameter, for example, that is being done in this question. So then comes the method of analysis. For this, what you need to do is bring this equation right here. Since this is not in linear form, you need to bring this into a linear equation, which is y is equals to mx plus c. And then you need to show that how are you going to analyze the results, right? And for the, you draw graphs, right? So for drawing a graph, you need a relationship between two quantities. So for that, you will need a linear equation. So then comes the additional details part with safety precautions, and you can also give the additional details in between these points. It is not necessary to do them in the end, but for safety precautions you can write them in the end. For this heading, we will see specifically for this question. So let's start making the diagram and writing our answer. So for diagram, there are some additional stuff that we need to draw, even though there was a diagram at the start of the question. Let's start with a support. Since we need to show the experiment with a wave, obviously there needs to be a support for one point of the cord to be fixed. So at this point the cord would be fixed. This is my cord and this is my pulley, and this is my load. Here comes the vibrator, just like the diagram. And one more thing, with the vibrator would be attached a signal generator. You can draw it like this and label it as G. Now you might be asking why a signal generator. So the signal generator supplies a small electric current at a specific frequency, which the vibrator converts into movement. So it is important that you're drawing a signal generator in this question. Now let's do the labeling. So you can label this as support. This is a pulley. Now, one important thing, this is an elastic cord. It's better that you write it that it is an elastic cord, because obviously we need an elastic cord to generate a wave, to make sure that this cord is able to curve, right? This is a load. This is our vibrator. And lastly, our signal generator. And make sure that you are drawing a circuit for the signal generator, because it produces an electric current. So the circuit is shown. Now this is our diagram pretty much. Let's start the question now. The answer. So as we discussed, let's write down our independent variable. Now here, the independent variable is obviously the cross section of the cord, right? Cross sectional area of the cord. This, and the student is investigating F, which is the frequency of the vibrator, and cross sectional areas of the cord, their relationship. So dependent is obviously frequency, since we're changing that, and due to cross sectional area, we are changing that, and since we are changing the section areas, frequency is changed due to cross sectional area being changed. So cross sectional area A is the independent in easier words, you can write vary A, measure F. Now, as we discussed, let's write our constants. So we have to keep M and L constant. M is the mass of the load and L is the distance between the two nodes. So keep L and M constant. We have discussed the first pointer. Moving on, let's look at our diagram. What additional did we do? We made a signal generator, so let's write about that. connect the vibrator to signal generator. Now with the help of signal generator, increase or decrease the frequency of signal generator until a stationary wave is observed. Now that we have written about the frequency, let's write about how can we measure mass and diameter of the cord. So measure mass of the load with top pan balance and measure diameter of the cord, diameter with vernier calipers using calipers. Now let's write about our method of analysis. For a graph, we need to convert the equation into a linear equation. So let's see how to do that. 1 over 2L under root M over Ka. This is our equation. So if we shift 2L with F, so it would become 2LF is equals to under root M over Ka. Now shifting this under root into square on the other side, so 2LF the whole square is equals to M over Ka. Now this becomes 4L square F square M over Ka. Now looking at this, we come to the conclusion that F square is equals to M over 4L square K into 1 over A. This is our linear equation, and the graph would be this on the y-axis and this on the x-axis. That means F square is directly proportional to 1 over A. So let's write method of analysis. Draw the graph of F square against 1 over A with F square on y-axis and 1 over A on x-axis. Since now how do we know that graph we drew or the result anyone has gotten from the graph is right or wrong? So since we know that F square is directly proportional to 1 over A, then the line of the graph obtained should be straight and passing through the origin. Okay, now one more thing. In the question, we read that explain how your results could be used to determine a value for k. This is very important, do not skip this. So your third point in the method of analysis should be about this. So we can write, since the gradient was equal to, our gradient was this, so we can just write that k would be equal to m over 4l square into gradient. Okay, since no, not a. So let's write down the additional details and safety considerations. So firstly, we can say that we should use something to caution if the mass that we are using, if it falls. So a safety precaution can be used Another thing that you might have been able to tell is that we should use the cord of the same material. So let's write that down. You can also write about how you can use a cathode ray oscilloscope to find out time period, and then you can use time period to find out the frequency. So let's write that. CRO. Since CRO is a common laboratory instrument that provides accurate time and amplitude measurements of voltage signals over a wide range of frequencies, determine T, and then you can write the formula that is used, which is method of determining T from CRO. There is a formula which is period is equals to time base, which could be found from CRO, and length of the wave, which is also noted from the CRO. One wave, right? And then using this, we can find out the frequency, since we will get the time period. Now, other than this, we mentioned for finding out the diameter of the cord, we should use vernier calipers. We may mention that. So a precaution for that, not a precaution, but you could say something to be taken care of. Whenever we are determining diameter of a cord or anything, we need to take measurements from the whole length, meaning from 3 different points on the cord, so that if there's any error, that could be minimized. So repeat measurements of diameter along cord, and then if when you have taken 3 different readings in at 3 different points on the cord, then take their average. This would minimize any error in the diameter reading. Okay, so an additional detail of how you are going to find out the cross-sectional area is, we before we just said we need to find out the cross-sectional area. We didn't give any additional details, so we can use the formula. Use of formula: A is equals to pi d square over 4 for finding out chord. So these many details and safety considerations are more than enough. So we are done with this question.